So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mask code at this side. Okay, so the question for the day is root to leaf path sum. What does the question say? The question is quite simple. You have a binary tree. You have a binary tree, right? That is a tree in which a node can have 0, 1 or 2 children, right? Now, you have been given the root. Obviously, this is the root. The 6th node is the root, right? Now, you have to identify all the leaves. You have to identify all the leaves. So, what are the leaf nodes? Leaf node is a node which does not have a right child or the left child. No left, no right. That is a leaf node. So what you will do, you will just say this is my leaf node because it doesn't have a left side. 3 is not a leaf node, 7 is a leaf node, 5 is a leaf node, and 5 is not a this 5 is not a leaf node. This 4 is a leaf node, right? Why 5 not a leaf node? Because 5 has a right child, right? Okay, now you have 1 2 3 4 leaf nodes, right? Now the problem says that you have to identify the path. So to reach the this leaf node, this 2, from the root, you will have to conquer the path 6 3 2. So write it down, 6 3 2. Similarly, for reaching this 7, you will have to conquer the path 6 3 5 7. For reaching 5, 6 3 5 5. For reaching 4, 6 5 4. Now, treat these paths as numbers. That is, this is the number 632, 6357, 6355, 6544. Add them up. That is this. And you have to give me the result as an output. Suppose after you sum of all of these 4 terms up, you will get an answer, right? You will get an answer, and that is the answer required by the question. That is the answer required by the question. It is a very beautiful question. For those of you who have not seen the binary tree videos, I have already uploaded a full playlist dedicated to learning how to master the binary tree, so please watch that. Next thing I want to let you know that in the playlist I have told you several times that whenever there is a question for binary tree, you have to think of traversal. You have to think of traversal. Now mainly there are 3 types of traversal: pre-order, post-order, in-order. In this specific question, you can use any of them. In this specific question, you can use any of them. For example, we are going through the pre-order traversal. So what does pre-order traversal say? Pre-order traversal says first explore your root, then go to your left child, then go to your right child. So what I'm going to do is going to see 6. I'm standing at 6 currently, right? Let me change thing. I'm standing at 6, right? My current value in my hand is 0, right? I will add 6 to the 0. That is 0 into 10 plus 6. Okay. This 6 will move forward to 3. When it will come to 3, it has 6 in hand. So 6 into 10 plus 3. That is the value at this node. This node at 3 is 63. Right, and it will send this value to 2. So 63 into 10 plus 2, that is equal to 632, right? And as soon as we encounter 2, we will see that this particular node 2 doesn't have a left child, doesn't have a right child. That means it is a leaf node. So add it to your final answer. Keep a final answer equal to 0 here, and then see that this is a leaf node. So answer equal to 0 plus 632. Similarly, from this 63, we will come here and it will become 635. From 635, it will become 6357 here and 6355 here. Both of them are leaf nodes, so add them up. That is, this term has already been done, this term is also getting done, and this term is also getting done. Similarly, this was the left child. For the right child, it will send 6 from here. After it becomes 6 here, it will get 65. 65 will be sent here and it will become 654, and we will add them up. Now, after adding these 4 up, we will get a final answer. So, what is my approach? What is my approach? My approach is fairly simple. Keep an answer equal to 0 as a global variable. This is your global variable, right? Make a traverse function. Make a traverse function, which will be taking my current node and my current value. See, if your node is null, you cannot do anything. In that case, simply return. What you have to run? You have to return nothing, because traverse will be a void type function, right? Return. Otherwise, what you will do? You will just simply say current changes to current multiplied by 10 plus node data. Plus node data. That is 63 will be changing to 635 as discussed, right? Moving forward, what I will do? I will say if this is a leaf node, so if root left, and I will have to use and if root right. If this is the case, what you will have to do? You will say answer plus equals to cur. the updated cur, right? And then you can simply return. Because it was a leaf node, I added to my final answer. Now go to the traverser for remaining one. That is traverse the node left with the updated cur only. And similarly traverse node right with cur, right? This is a simple thing you have to do. The driver function will call traverse node with root being sent and cur value set to 0, right? And that's all. At last you will just return your answer, which will be stored, right? So it is quite evident that I'm doing a simple traversal, so time complexity will be O of n. O of n is my time complexity, and my space complexity is recursive stack space, that is equals to O of log n. That's all. That's all. Right? I hope this is quite enough for you to understand. This doesn't require much more understanding, and it's time for us to see the code for it. So here is the coding section, guys. Starting off directly, what I will do, I will say traverse with the current root and let us set the value 0 and return answer. So I will have to declare a global answer. So int answer equal to 0 declared, and similarly void traverse node star root and int current, right? First thing, if my root is null, in that case return simply, because I cannot do anything if I am encountering a null node. Otherwise update your cur. So cur equals to cur star 10 plus root data. My current updated. Now go to traverse the left child of the root, right, with the current value. Go to traverse the right child of the root with the current value, and then you can return, right? Before it, or you can do it in between or after also, because the traversal here doesn't matter, because we are sending the cur with the brackets only, with the arguments only. It is not a global variable, right? So if my root doesn't have a left child and a right child, that is, it is a leaf node. In that case, my answer will get updated. So answer plus equals to cur, right? That's all. Let us try to compile and run this code. Hope it will work fine and will not give any error. Working fine for the sample test case. Let us see for the submission also. So it is working quite fine, and thank you for watching. Hope you liked it, and make sure to subscribe to the channel, and I will bring much more content to you. Thank you. Have a nice day.